This is a review of Chapter 6. As I've said before, this is probably the most important chapter in the book. To get through this course with as much knowledge as you can, you have to have a basic understanding of the refrigeration cycle. And I know some of you already do, but there's things within the refrigeration cycle that have to be mastered to be able to look at problems when you look at a unit and be able to understand why these things are happening. So on page 90, the second chapter, the second paragraph down it talks about how refrigeration is like a sponge and soaking up heat and then squeezing out heat. And if you look at the diagram or the figure 6-1, it makes it look like this is how it works. The refrigerant leaves the compressor and it is full of heat at this point, heat that it's recovered and manufactured in the compression cycle. And at that point, the heat is going to be released by squeezing that sponge and getting rid of the heat. As it goes through the system, it goes to the evaporative coil, and that sponge actually is like absorbing the heat that's in the house. And that cycle continues. And that's a good way to look at it, that we are expelling heat that we picked up in the home in the outside condensing coil and going through a cycle again, picking more heat inside the home and going back out. Now, this is not a one continuous squeezing and releasing. It's more of a process that works nonstop as long as your unit's running. On page 91, high side and low side, there is this figure, which is 6.2. It is not seen very well on my screen, and I apologize for this video. I wanted you to see where I find this information at. You can get to the same information that I'm getting to online, but the book is much easier to look at this. So if you have your book, go ahead and open it to page 91. We have a cycle here of the compressor on the bottom left, sending the high pressure, high temperature gas to the condensing coil. As it runs through the condenser, there's a fan that cools the refrigerant slightly, somewhere in the 10-degree range, which starts the change of state. It starts condensing the vapor into a liquid. As it passes through the coil, it completely changes it to liquid, and it needs to do that to work. The liquid line runs up through the system to the top of this picture to the metering device, that X. Meters the amount of refrigerant, a small amount going into the evaporative coil. And as it goes through, the liquid will boil off and turn into a vapor, constantly using latent heat to pull as much heat out of the air, or accept as much heat, I should say, out of the air before it sends the low pressure, low temperature vapor back to the compressor. And in this picture, they have a dotted line running from the bottom of the compressor to the top of the metering device, which shows it as a division between the high side on the right and the low side on the left. And that's a very important spot, because to diagnose a unit, you have to know where the problem exists, either on the high side or the low side. And down here we have this little diagram showing you what the pressures are at that point. The light blue is low pressure vapor. The darker blue is low pressure liquid. The pink or light red is high pressure vapor, and the red is high pressure liquid. Page 92 it's 6.3. covers compression. This is the cycle that the compressor works on. The important part about this is that without taking the refrigerant, which is a low pressure, low temperature vapor, going into the compressor and doing the compression cycle, it raises the heat and raises the temperature of that refrigerant. The system would not work. Moving it through is one thing. I mean, it's not just a pump, and a lot of people describe the compressor as a pump. It's not actually a pump. A pump doesn't compress. So a garden hose, it sends water out, and you could be using a pump to pump the water through a garden hose, but until that water is condensed into a smaller form and changes its temperature and its state, it's not going to do anything for you. But in this system, the compressor is actually changing the makeup of the refrigerant. And on page 93, you have the compressor diagram. The compressor is, in this picture, is a piston. They're mainly in refrigeration units right now. They're a little bit different. Most air conditioning systems are using the scroll compressor, which looks different, but they do the same job. The left-hand picture shows the piston in the down position. It opens a suction valve and allows the refrigerant to enter. The suction valve closes, and also the discharge line is closed valve. The piston gets pushed up and condenses all that refrigerant into a smaller section. And at that point, the discharge valve opens and the high pressure, high temperature vapor escapes. The process in what happens in here is the molecules of the refrigerant, when they get compressed, they start running into each other in a smaller area, a little more confined space, and it raises the temperature and the pressure of the refrigerant. On page 94, you will not have any questions on an oil separator, although when you get into other chapters, there's going to be information on them. I'm not going to cover it here. It's just not something in the industry you'll work with unless you're working with large chillers. You might have to deal with oil separating devices. But on our normal air conditioning compressors, they're hermetic, they're sealed. You don't get into them, you don't do anything with them, so I will not spend a lot of time on this. On page 95, here we're looking at condensing coils. The coil on the left is a picture of one on the back of most refrigerators. Nowadays, you see them less on the back of the refrigerators. This is a mainly old type unit. Now they're underneath, and there's a fan that blows air. If you've ever had an animal and it's cold in the winter and the house is a little chilly, the animals sleep or lie down in front of the refrigerator because there's warm air coming out. When the refrigerator works, the compressor makes that heat, and to dissipate the heat that's in the high pressure, high temperature gas, it goes through the condensing coil, which is underneath the unit, and it actually blows warm air out. Not very much, but it still blows warm air out in front of the air conditioning. Or I'm sorry, the refrigerator. The diagram, or picture B, is a condensing unit. This could be a remote unit, a mini split of some sort. This can be a refrigeration unit. It's a condenser sitting on a roof on top of a building. It's just a coil. It's not a compressor or anything like that. It's just the coil trying to get some ambient air to cool off the refrigerant. Page 96 is liquid receivers. There's all different kinds on this page. There are all different ways that these work. In residential air conditioning, you'll see accumulators that are a liquid receiver for heat pump systems, but that's pretty much the only ones you'll see. Again, when you get into chillers and larger commercial systems in the future chapters, you'll see different ones. Liquid line dryers. This is this section right here. The picture below is a liquid line dryer. A few things about this. Most systems should have a dryer on it. If you're installing a brand new system, and this is something you really should have on the system. The dryer can be a permanent function, or you might put it on just for a short period to make sure the lines in the system is empty and can come back and remove these. Some dryers come with fittings on them, flared fittings that you can take it off and put a piece of section in between it, or you can remove them. But most companies recommend you put a liquid line dryer. Some already have them on them, or with Goodman products, they usually have a little baggie with it hanging on it, so you can put it where you want on the system. This takes the moisture and debris out of the system. This one has a port or a valve stem there that you can put your gauges on. And the reason you have this is the back end of the system, and this is where the stoppage happens. So you could tell if the system is not working properly because of a clogged liquid line dryer, and you could test the pressure to see if the pressure changes between this side and the outward side of this unit. We're also covering metering devices on this page. The metering device is the item that controls the amount of refrigerant that comes on the liquid line, goes into the evaporative coil. If you were to flood that evaporative coil with all that refrigerant, you would never get to the point where you're accepting enough heat out of the air to make a difference. So in this case, it has to meter a small amount, and every unit's different, every coil is different, so that the refrigerant can boil off, turn into a vapor, and start to cycle all over again. Because at that point where it's boiling off, that's where we hit latent heat, and it accepts the most amount of heat. And how this works with a boiling pot of water, and we saw that video, and I might attach it to the end of this presentation as well, is when the water gets to a point where it starts boiling, the water temperature doesn't change. It stays at 200 and some degrees depending on your altitude where you're boiling the water and the pressure inside the cylinder. But the water does not continually going up to temperature. You can have a 500 or 600 degree flame underneath it. That water always stays at 200. The difference is the change of state. That steam going up is accepting all that heat that's below that water. And that's where it makes a difference. Being able to accept more heat with the same amount of energy is what's important to make this work.